Alright, welcome back. Now, in this video, we are going to look at solution to Cauchy-Euler equation. Solution to Cauchy-Euler equation. Trust me, it's going to be interesting for us. It's going to be interesting for us all. So, let's first talk about the idea behind all these things. Let's talk about the idea. So, let us consider the homogeneous form of the Cauchy equation. Don't forget that all those Cauchy equations that we are going to consider here, they will all be equating to 0. That is a homogeneous equation. Alright, now this Cauchy-Euler equation is the same as variable coefficients. Don't forget, in our previous video, we went through about 3 cases in going through how to solve when we have a constant coefficient. In the same way, we are going to look at how to solve when we have a variable coefficient. Very good. And I think I don't need to talk more. Alright, I don't need to talk more about this. Now, how do we identify that this is an Euler or this is a Cauchy-Euler equation? Very good. When you consider this second order differential equation, you can see that the variable here, this is just a constant. The A2, A1, A of 0, they are all constants. So I think that's not the focus here. But the focus is the variable, is the variables. Alright. Now you can see that this is a second order, and the variable here, which is S, is of power 2. Alright? Second order power 2. And the variable here power 2. Look at this. Power 1. Look at this. Power 1. Look at this. Power 0. And like that. Very good. So, this is a second order Cauchy-Euler equation. Alright. In general, we focus on the first one. We always focus on the first one, which is naming the order, because even if you have y prime plus y is equal to 0, this will still be bad. We don't have the second order in it, but this will still be the first order, because this is defining it to be the first order equation. So we always consider whether the variable here is the same as the order here. That is all. That is all. And this, let's assume that we have. Let's look at some of the examples. Then after that, we see how to write a characteristic equation for constant coefficients. It's not the same way as writing it in Cauchy-Euler equation. Very good. So for instance, this can be written as f square y prime plus a1 x y prime plus a of 0 y is equal to 0. How we can see that? Very good. Power 2 under 2. That's how we check it. The rest is not the focus. And don't forget, this one can be equal to 0. Because for the constant a to be equal to 0, it will cease to be a Cauchy-Euler equation of order 2. Alright, very good. So now, let me just go straight to the point and show you how to write the characteristics equation. So focus here. For instance, if we have y prime plus y prime plus y is equal to 0. To write the Cauchy-Euler equation, let me write the x squared, the x, then that's will be here. Very good. So in this case, this is how we write the Cauchy-Euler equation. This is how we write the Cauchy-Euler. Alright, now let's look at how we write the characteristic equation in Euler or Cauchy-Euler form. Alright. So this is a second order Cauchy-Euler equation. This is a second order Cauchy-Euler equation. Why is it a Cauchy equation? Because the variable power here is the same as the other here. The variable power here is the same as the other here. For instance, if you have x y prime 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 plus y prime prime or plus x square y prime prime plus y equal to 0. Now this is not a Cauchy, even if here is square, it's still not a Cauchy-Euler equation because of the power here is not the same as the other here. Power 3 order 3, no, it doesn't match. So this is not a Cauchy-Euler equation. Now let's see how we write the characteristics. So this is how we write the characteristic equation for the second order. Alright, the variable won't be counted here. So this we write lambda minus 1 plus 2 lambda minus 2 equal to 0. This is how we write the characteristics equation. Alright, and for you to solve it, you just simplify this to get a polynomial function. Very good. This is a third order. Let's look at how we write the characteristic equation for a third order. Second order, third order. So lambda will come first. Lambda minus 1. Down here, if it's the first order, you end. But in the third order, you don't end. Then you move on to lambda minus 2. Alright, very good. So you can see first order, second order, end at, or power 2 end at 1, power 3 will end at 2. Then we get plus, what is here is minus. Then this is a second order. So lambda minus 1. Second order end at 2. Plus 2. Yes, don't forget to bring this constant. But the variable will not come. But this is a constant. So 2. They just first order. So lambda minus 2 because it is a function equal to 0. So that is how we write for a third order differential equation. Watch again. Lambda minus 1 multiplied by lambda minus 2 like that. That's how we write a third order differential equation. A third order differential equation. Very good. Let's consider fourth order. You see, fourth order will be power 4 y prime. Okay. You can bring 2 y prime. In this case, I would like to make it this way. Please, if you can see, it's 3y equal to 0. Alright, so let's see how we write the characteristic equation. Lambda minus 1, lambda minus 2, lambda minus 3, fourth order n at 3, plus 2, lambda minus 1, lambda minus 2, third order n at 2. Hope you can see that. Second order n at 1 plus 2 lambda plus 3 equals to 0. So that is how we write the characteristics equation. You can give yourself an example and try it your own. Alright, so our next step, we are going to look at how to write how to find the general solution. We are going to look at how to solve the general solution. Alright, But here we are going to be using the same idea that we did in our previous video about constant coefficient. But what we will be doing is that we are not going to leave the general equation like this. For instance, this. We are not going to leave this in the form of x, but rather in the form of t. T. In the form of t. Alright. Then we transform. Then we are going to transform x to be equal to e raised to, so we transform x to be equal to e raised to t. Alright. So here we can take ln of both sides. You can take ln of both sides and do whatever you want to do. Very good. So when you take ln of both sides, let's do that. Ln. You see that we get ln x is equal to t ln e. This cancel this. Hope you can see that. So t will be equal to ln x. So wherever we see t, then we put ln x there. That is how we are going to do it. That's how we are going to do it. Alright. Note that since x is a function of t and y is a function of x, then y is also a function of t by transitivity. Very good. Very good. Alright. So when we start solving question, you get to know what all these things mean. Very good. In the same way, the characteristic equation, this characteristic equation can end up by getting two rare but distinct roots. We can also get repeated roots and also the last one, the complex root. We can be getting like that. So let's start with the first question. Alright, so let's consider our first example under the Cauchy-Euler equation. Very good. Find the general solution of the differential equation. Bam. In fact, in the question, nobody will tell you. In fact, see, we are doing Cauchy-Euler equation as a topic there. So you can see that, oh, definitely, this is a Cauchy-Euler equation. You see, but in the question, if it's in exams, nobody will tell you this is a Cauchy-Euler equation. You have to identify that this is a Cauchy-Euler equation. So I'm going with that method. Is that clear? Very good. So you can see a variable coefficient. Power is the same as the other. So it's a Cauchy-Euler equation. Very good. Alright, so let's write the characteristic equation. Then we go and simplify it. This times this, lambda squared. This times this minus lambda plus 2 lambda minus 2 equals to 0. This plus lambda minus 2 equals to 0. Then you take your calculator, do as such. Okay, so you can see that this we get lambda 1 to be equal to 1, lambda 2, and lambda 2 to be equal to negative 2. Alright, so you can see this one is a distinct root. It's a distinct root. Very good. Alright, so we write it as I said in terms of what t. raised to the power lambda t. Okay, very good. So let's write the general equation. So C1, the same way as we did in our previous video, e raised to the power. Now the first lambda is 1. So this is just t plus second constant. E raised to the power lambda is negative 2t. Very good. Alright. But we need to get it in terms of what? X. So we put x to be equal to e raised to the power t. Alright, so let's look at this question. How are we going to see where they are coming from? Very good. So let's start with the fourth one. Okay. So this is the fourth order, right? But is this one a Cauchy or not a Cauchy? Very good. It's not a Cauchy because there is no variable in it. This is a constant coefficient. Constant coefficient. Alright. So this one straightforward. Lambda power 3 plus 13 lambda squared plus 55 lambda plus 75 equal to 0. Alright, so with this, you continue to solve it. And when you solve that, you are going to get a multiplicity of this. So here, you are going to get this to be negative 5, and 3. So there is a multiplicity of, negative 3. So there is a multiplicity of negative 5 here. Alright, very good. So you go on to write the general equation. So the general equation is going to be, don't forget this one is not going to be term of t because it's not Cauchy that we are dealing with. This is just a constant coefficient. So C1 e raised to the power negative 5s plus C2 s e raised to the power negative 5s plus, so 1 is here, okay, so we left the last one, C3 e raised to the power negative 3s. Alright, so that's what is going to be the solution to that. So we'll be looking at the rest of the questions. You can pause the video also and try to solve it on your own. The fifth one also is a constant coefficient, alright? So power 4 plus 2 power 3 minus 5 lambda squared minus 6 lambda plus 100 is equal to 0, alright? Very good. Then straightforward, you go on to find the solution to that or the roots for that. Very good. So with this, there's going to be a multiplicity of 2 here and 3, 4. So you see that on your calculator, you take only this and this. If you use Tesla's instrument, it will show you negative 3. Alright, for you to see that there is a repetition of 2 here, there is repetition of 2 here. Then you move on to write your general solution. And quickly, this one too is going to give you this, establish this. Alright, that establish that. Then we move on for this. Alright, so that is that. Yes, sir. Yeah, yes, sir. Let's look at the 6-1. This. Now you can see that this one is a Cauchy. Hope you can see that. Variable coefficient. With initial values. Variable coefficient. Very good. So let's go and look at that. So we write the characteristics equation first. Then we go and solve that. And this simplifies to lambda square minus 4 lambda plus 3 equal to 0. So you get a repetition here, 3, and this one is 1. Alright. It's a quadratic, so it's clear. If you don't want it this way, you can write it as very good. So you go on to write the characteristics equation. It's Cauchy, so it's supposed to be in terms of t. Always don't forget that. And this one is c1 e raised to the power 3t plus c2 e raised to the power t. Okay. Then you put t to be equal to the s. You put t to be equal to the s. So you end up by getting so this will be our 3. Hope you can see that. So you get C1 F equals A plus. So this is going to be a general solution. Alright. But because of this initial value, then we need to go and differentiate this y. We need to go and find the first derivative. So the first derivative, we are going to get 3s squared plus c2. Alright. That's what you're going to get for the first derivative. For the first derivative. So we move on to go and do the substitution. So this means that we are replacing it in a function. Let me go and clean this slide. I just want to wrap up with this thing. This stuff. So the function is equal to 1. This is 0. Alright. So now 0 here, 0 there. Oh, so this is telling you that there is a mistake somewhere. Let's look at it. That was the same video. Alright, so you can move on with this, with the IDP and get your solution. Okay, let's look at the last one. This one too is a constant coefficient. Alright, it's a fourth order. It's a fourth order. So let's go for that's why we have 4 IDP. 1, 2, 3, 4 to get the particular solution. To get the particular solution. So go for that. Alright, so let's look at this Cauchy, but I'll leave this one for you to try it on your own. Let's try on this. So we move on to write the characteristics equation. Alright, so with this will simplify to lambda square minus lambda plus 1 equal to 0. So lambda square, this and this, 0. So we can see that plus 1 is equal to 0. Alright, then now having this, you can send this to the side, negative 1, right? But when we take the square root of both sides, this cancel this, so lambda will be equal to plus or minus square root of negative 1. Now you know that square root of negative 1 is I. That's going to give you I. Very good. So this one is in the form lambda 1, 2, second order. This is in the form 0 plus or minus I. So alpha is equal to 0, beta is equal to 1. Alright. So we move on to write the general solution. Please write this on your own. So we move on to write the general solution. Y of t is equal to so we do the substitution. Y of t is equal to alpha is 0, 0 t. Beta is 1, so t. N average upon 0 is 1. Then we put t to equal to s. So what this means that wherever you see t, put in s there. Alright, so this becomes the general solution. Don't forget that we are given some IVB. Let's go for that. So let's use the first IVB that says this. This 0 or 1. Yeah, I think that place is 1. Alright. So 1 is equal to this 0 or 1. Yeah, I think so. Alright, so now this is equal to negative c1 plus 0. Alright, that is when you take the mean of it. Because I'm coming to check something. You see, we can't take the mean of 0. So here is 1, it's not 0. You can't take the mean of 0. So when you take the mean of 1, that's what you're going to get. So you end up by getting c1 to be equal to negative 1. C1 will be equal to negative 2. Then at y of 1 is equal to 2. We move on to do the substitution, but before that, this is y prime, so we need to take the derivative of this. So y prime is equal to c1 sin x over 1 over x plus c to be just the